All right, I'm going to do a retake of the video here, data engineering and everything. And that's because I got a lot of positive feedback, but also feedback like close the blinds, right? Use a microphone, use a black marker. So it's going to be the same content again, this time with a black marker and a better microphone. Hopefully, let's see if this works. And the blinds closed. Okay, 95% the same content. We're going to talk about what is data engineering, what are data pipelines, how do I get data, right? So it all starts with something we call a production database. So I talked about you have United Airlines and you're selling tickets. And for that you have a database, okay? Whenever you go to United's website, let's say you book a flight and that flight ticket ends up in something called a production database. No confusion around, is it NoSQL, SQL, big data, Mongo, all of that. Just take it as what it is, a production database. And so that's why we're going to call it production. Okay? And these databases are optimized for writes. Right? They're optimized for getting lots of data in a fast amount of time. Because if a lot of people are on United's website concurrently, United wants to make sure that you can process these transactions as fast as possible and book the sale, right? And because it's transactions, that's why another word for these production databases is also OLTP. Online transaction processing. Now, this is a term, hear it once, then you can forget it, but it may pop up in some of these meetings when you have engineering meetings, and when somebody says OLTP, you're like, oh, transaction processing. So this is my production database, this is how I run my business. And so United now sells flights over the course of a month, and then obviously the CEO or whoever, finance, wants to know, well, how many tickets did we sell, right? And what you can do now is a couple of things. Now you can write something called a query. The query says like, how many tickets did we sell in the month of May? If you do that once, that's okay, right? But obviously you want to know it across the whole business. You want to know it by channel. You want to know it by flight leg, by ticket price, whatever it is. Did we sell it through a mobile app? Did we sell it through a web app? And so the queries get bigger and bigger, and maybe more people want to ask questions, write that kind of query. And so what would happen is if you did this, these queries to ask questions about the business would compete with these write queries, with people trying to transact business with United. And that would slow down the database, right? Because it competes with it. A database is always finite resources. And so if you start writing other stuff and selling tickets, it's going to slow down the database. What happens when a website slows down? People go away, right? They go to Delta and buy their tickets here. So you don't want to do that, right? You can't run your analytics on your production database. So what's the solution to that? Well, you move that data into a separate place where you can query it, right? And that's where a second database comes in. This is also a database, right? And in this case, it's a specific database for analytics. Analytics, okay? So these databases, and another word for this is data warehouse, these databases are optimized for lots of reads, right? So getting data out. Up. So these are reads. So people can write lots of queries like how many flights did we sell from LA to Boston on what day, like slice and dice in any way you can, right? And so and this is then your analytics database. And the other term here is something called OLAP. Online analytical processing. And so the solution to avoiding to put analytical workloads on your production database is to move it into a separate database dedicated to analytics, right? And that's your data warehouse. Data warehouses include Snowflake, Amazon Redshift, Google BigQuery. In the old world, on-premise, it was Teradata and Oracle. These days, everything shifts to the cloud. The four big ones are Redshift, Snowflake, BigQuery, and Azure SQL Data Warehouse. Those are the upcomings. So now that leaves us with the question, well, how do I get the data from here from my production databases into my analytical data warehouse, right? How do I do that? And that's a process called ETL. And I'm going to write this here, and I'm going to tell you. So first step is you need to extract it from your production database. That's the E, okay? Then the next step is you need to transform it in a way that it's good for reading it, right? Lots of detail how you do that, just accept it as the T in ETL, okay? And then the final step is now you need to load it into your destination, into your data warehouse. So this is the term you will hear in data engineering. Hey, we have to ETL this data. We got to extract, transform, and load it. And in the old world, this was a company like Informatica. They built like a multi-billion-dollar business just around doing that. What we see changing in this new world, there's a bunch of new cloud providers like Fivetran, Illuma. They've built these ETL tools for the cloud that help you move your data from your cloud production database into your cloud warehouse. And that's what ETL does. And you may also hear like ELT, they're switching it up, but that's a topic for a different video. Just extract it, transform it, load it. Keep that in mind, right? So the three terms, OLTP, ETL, OLAP, engineers love acronyms. Now you will remember forever when somebody talks about that, okay? So now you're in a situation, you have ETL all your production data to your analytical warehouse, and now you can write queries. And we talked about how there's a hierarchy of needs, a little bit like Maslow's hierarchy of needs. At the very bottom, you have something, you have reporting, right? How many flights did we sell? Let's do this here, reporting. Right? This is like for reporting to the street, finance and everything. How many flights did we sell, right? How many flights did we sell to foreigners? How many flights did we sell for going from San Francisco to New York City? Then on top of that, you have analytics. A little bit more sophisticated queries. Maybe also predictive. How many flights will we sell next month, right? Based on historic transaction data, patterns and everything that we have, like, you know, where will we land if these parameters are true? So that's predictive analytics. And then you probably have heard about machine learning by now, and I'm going to use this as ML, right? So machine learning, that's the latest craze, and then on top of that is AI, artificial intelligence, right? Where there's almost no more humans involved. You just write the algorithm. That's what data scientists do, and then those algorithms make decisions as machines on behalf of the business. So then what happens now is what all these things have in common. Obviously, the further you go up here, the more sophisticated it gets, and the more data science is involved. But what all these things have in common is that they need lots of data, right? And part of that data comes from the data warehouse, right? Because reporting needs data, analytics needs data, machine learning needs boatloads of data, and that actually has become possible via cloud warehouses. They've driven down the cost to store, process, and analyze data, and that is the reason why you've seen all the machine learning and AI ads out there, because we're now in a phase where the cloud has driven down prices for storing, processing, and anything around data so down to rock bottom level that this has become affordable. And so this is your process, right? Here's your production database. That's where you collect all the data. Then you want to analyze it, so you're going to put it into your analytical data warehouse. The process to get there is called ETL, extract, transform, load. Now here's your data hierarchy of needs, like what is your business going to do? Now, and then the people who do all of this, right? Those are the data engineers. They do this, right? This is your data pipeline. You will hear that term. Building this is super complex, by the way, right? So like we're talking about terabytes of data, streaming data really fast. Like it's tons of engineering you need to do, software engineering. And then here you have your data consumers, maybe also data scientists who write these models. And then people also ask me, well, what does Intermix do? What does your company do? Well, we're talking about hundreds of people accessing this data, terabytes of data flying around in real time, near real time. So what Intermix does is, if you're the data engineering team in charge of that, it's really complex to hold everything together because the information in these systems is spread across and you don't know what's going on, right? Like my query is slow, my model is failing. Why is that the case, right? So what we do is we have probes here in a very simple term. We know what's going on here. We have probes here in your data warehouse, so we know what's going on here, who's touching your data. We have probes, let's call them probes or agents here. So we know who's querying your data, who's running queries on your warehouse. We put all of this together, okay? this information and we present it in one single dashboard, that if you're the data engineer, it puts you in control of the state, right? And you know what's going on, who's touching your data, who's querying your data, and you're not in a situation where you're surprised because something spins up, the whole stack goes down, you see that coming with us. And you can also save and fine tune on your infrastructure, so save costs, because one of the trends we see as more and more companies become data centric, the cost of running this is going up, and it actually becomes part of your cost of goods sold. So you need to be in control of your costs. So these are the things we do. We tell you if everything is healthy. We tell you who's running queries and how much they're costing them and what you can do to improve the performance and the cost of this infrastructure. So a little bit different content this time, 95% the same, a few other things. Post your questions for the next video down here. And I hope this works now. Larger, black pen, better lighting, better microphone. So if you're in the US, happy 4th of July.